Hello, welcome to OCC Math Seminar video. Today's section is about derivative and average rate of change. The average rate of change of f over the interval from a to a plus h is equal to f of a plus h minus f of a e over h, right? So the average rate of change rather is represent the slope of a secant line, right? So this represents the slope of the secant line. Right, so let's see. If I have a graph, say it look like this, say it look like that. And here's my point C, and here's my point H, right? So the secant line is just the line that go through those 2 points. C, I have the y function will be f of C, right? And H, and then I have C plus H. So right here, I got C plus H. I should have said C plus H here. This is C plus H, right? Here I have F of C plus H. Right, so that is the average rate of change. Represent the slope of a secant line. Now, the derivative f at A is defined at the rate of change of f at x, right? So this is instantaneous rate. We're not talking about the average rate of change, right? You're not driving your car at one speed overall, right? You rather change it fast or slow, depend how the condition, right? So the derivative allow you to calculate the rate that change at the moment, at the instantaneous moment. We call that f prime of x is equal to limit at h approaches 0. So when h approaches 0, so this thing collapse. This thing collapse. Now we have a tangent line instead of a secant line. Then limit at h approaches 0 of f of a plus h minus f of a is divided by h. The reason being is when h is get closer and closer to 0, is collapse to 0, then the secant line get closer and closer to the tangent line, right? Therefore, we have the only difference is that when limit at h approaches 0, the secant line get closer and closer to the tangent line. Right, so this is the definition of the derivative. I don't think you have to memorize this. Most professors will, if they want you to evaluate derivative using the definition, then they'll give you the formula. All you have to do is just plug in the values. Right? So let's take a look at a problem here. Oh, if limit exists, then f said to be differentiable at A. Right? Now, differentiable equation is continuous everywhere, but it's not the other way around, right? Not all continuous functions are differentiable. All right, I want to find the derivative of f of x equal 3 minus x squared by using the limit process, meaning this one. And again, I believe the professor will give you the formula. Right? If you want to remember it, it's not too bad, not too long. Okay. So now I'm going to plug in some value. F of x is 3 minus x squared. What is f of x plus h? Well, it's equal to 3 minus, instead of x, you're going to have a new block here, x plus h squared, right? I'm thinking that should I expand it now? I think I should. So I have 3 minus, in here you can use the Pascal triangle, or you can expand it into 2 binomials and then FOIL it. I'm going to use the Pascal triangle here. So it'll be x squared plus 2xh plus h squared. Distribute the negative. I have 3 minus x squared minus 2xh minus h squared. Now I'm going to plug it in. So f prime of x is equal limit as h approaches 0 of f of x plus h, which is 3 minus x squared minus 2xh minus h squared, minus f of x minus 3 minus x squared. Make sure you put a parenthesis around the f of x function over h. Now, I don't feel like writing the next step, so I'm going to distribute the negative here for the f of x function. So when I remove the parenthesis, it changes size, right? So minus 3 plus x squared. We have some cancellation here to do. I see this one with this one. Also, the 3 and the minus 3, right? Right, what's left over is minus 2xh minus h squared over h. I'm going to factor out that h. So equal limit as h approaches 0. Factor out the h, I have negative 2x minus h over h. This one cancel with this one on the bottom. So I have limit at h approaches 0 of negative 2x minus h. Now I can plug in 0 for h, right? So limit at h approaches 0 of negative 2x minus 0, right? Which is equal to minus 2x, right? Minus 2x is independent with h. So that will be our derivative. Right. Thank you for watching.